Well, just a few words of introduction to the BAA. To let you know how we were organised, we have a president who's elected for a period of 1 year, and then we have section directors, and they tend to be in post for quite a long time. So, for example, Dr. Richard Miles is the remote planet director, and he's currently doing work on asteroids and measuring the rotational period by photometry. I'm always keen to see younger people in the audience, because whenever I attend a meeting, we all seem to be getting older, and we do need to encourage youngsters to come forward. Professor Leveridge is the director of the lunar section, and I think that's where most young people start to look at the night sky. Right. I wasn't expected to be thrust into this role of presenting this, because I had hoped that Roger might have been here, or one of the other main section, variable star section people. We have a telescopic program, and we also have a binocular program. And an eclipsing binary section, and they use DES just uses an ordinary DSLR mounted on a tripod with a fairly long focus telephoto lens. Well, coming back to our database, if we can start with the presentation. We have over 2 million visual and CCD observations. We are the oldest in the world with observations dating back to 1862. Over 2,000 stars are monitored. We have over 900 observers. Quite a few of these observers have monitored over 100,000 observations. There's 30 stars with more than 10,000 observations. What we do is we have a variable star of the year, and this year it is RR Tauri. Anyone can view light curves and download data using that link. Right, the history of the VSS database. Visual database, established in the 1990s. We have light curves and data tables which can be created quickly. We have had a very long period of loading historic observations that were in paper documents. And that's still ongoing. And it's still in use. Right, the visual database. The drawback of the initial database was that only the secretary had access to it. Therefore, he was required to produce data when requested, and
if you have interesting stars,
coordinating the loading of data that was sent through to him. So his workload was quite heavy, and he's given up this year. The CCD database quite different observation information to be recorded. In early 2000s, Andrew Wilson created a new database for the CCD data. He's the director of the computing section. Initially, just to test what we were doing, we just recorded a single comparison star and a check star. It now records an unlimited number of comparison stars. Ideally, observers submit instrumental magnitudes to allow reduction of observations. However, the database also accepts simple derived magnitudes of the variable star only. Online database development was necessary to redesign the databases so that it could be easily accessed via the internet. A graphic representation was also required in the form of a light curve. Also, necessarily, the light curve could be manipulated so that different time sections of the data could be viewed, as well as the full plot. A search facility was added due to the number of recorded stars and the multiple designations that a star can have these days. Observer and filter details are also included, as we will see. Finally, the online database goes live. 1st of January 2012, the new online database went live, and it contains both the full visual and CCD observations. It enables anyone to easily review and download data. This is merely phase 1 of a complete overhaul of the EuroVS databases. Phase 2 will allow observers to submit observations online, should they wish to do so. And I think that we've now reached the stage where phase 2 is capable of doing that for visual observations. Once this has happened, then the old visual and CC databases will be decommissioned. Accessing data. So that is our website. And this is how you can access light curves and other data and sections of light curves. Access the EuroVS database there. Review data for a star. I then submit the object we wish to see and the parameters. So picked RR Tori, which I explained was variable start of the year. So we're now going to generate a light curve. That's a light curve for RR Tori, and it gives details of who the observers were. If we want to go into a particular section of the light curve, this can be selected and zoom in. And it gives details of negative observations are across. Triangle is brighter than, otherwise circles is visual, and the diamond is the CCD. The results of zooming in, we can zoom in further. So it enables you to look in detail at a particular part of the light curve. The result of zooming in further, the image of RR Tori and its associated nebula by Graham Wells. The table of data can be downloaded. And details of the individual observers can be seen, together with the method, if filters were used, we try to mostly use V-filters if we're just doing visual observations. Observational parameters. You can search for a star using the filter box. This will also search alternative designations which are not in the main list. The date range is in UT or JD, and they can both be converted to one or the other. And you can deselect any observational method that are not required. And select filters and observers as required. Other selected stars in the database. This is a light curve for Z. Ursa Minoris. And you can see the crosses where the negative observations. The light curve for CG Draconis. All the data. With zooming in, and the CCD observations are the buttons on the form. For a start, we do do ask that our data be acknowledged. So we're complete to 2010, but it's ongoing for 2011. Other buttons, variable star alias names, observers and sequences. The variable star lists all the stars in the database, more than 2,000. Star alias names. Sequences just lists all sequences and other data of little interest to the average observer. And observers, including summary, takes you here. So it gives the details of individual observers, and they are from around the world. And say you want to pick Roger Pickard, for example, this will reveal a summary of what he's done. In the old days, he was doing photographic work. And see how the explosion of CCD observations has taken over from visual. 4,008 visual and 73,000 CCD. And it gives details of the minimum and maximum, the variable, the number of observations, and the minimum and the maximum magnitudes. Our database has the unique ability to reduce magnitudes. This is immensely useful when sequence magnitudes are updated with improved photometry. This is made possible by two critical factors. The full measurement is recorded as in a visual observation B2B 3C. I'm sure you're all familiar with that method. The database contains the sequence magnitudes. This means that observations spanning many years using different sequences can be reduced to give results based on the same modern sequences of magnitudes. This capability is built into both the CCD and visual databases. The BAA VSS observing programs. The section divides the stars it observes into several programs. Telescopic, which consists of our old favourites, Limaras, that can be predicted, eruptives, CVs and other types. Binocular, mainly red semi-regulars. Recurrent objects, generally covers unobserved CVs with periods in excess of 1 year. Eclipsing binaries, mainly for visual observers, but CCD and DSLR now being contributed. The advantage of doing visual observations is that you can monitor a star for quite a long period, and when you see something happening, an eruption taking place, for example, then the CCD observers can then concentrate on that object. Our visual observing programs is a nova-supernova search in conjunction with the deep sky section of the BAA and the Astronomical magazine. Over 240 supernova discoveries have now been made by UK observers. So there's still work to be done if you're looking for a supernova. Eclipsing dwarf nova, we've set up an attempt to discover eclipses in these objects. Identification, classification and correction of errors, and also checking on the discovery of new observers, new variables. CCD designed to help those with CCDs to obtain scientific results and covers CVs in the main, but not exclusively, because I think I found it quite difficult to get started with a CCD camera, having been a visual observer, and the help you can obtain from Richard Miles and others. And we've also produced a guide on how to do this, which is on the counter there. The future. Online submission of data. Displaying both the date and the JD when viewing light curves. Option to display and download reduced magnitudes as well as your original observed magnitude. More as the need may arise. Summary. Online database is a great improvement on what was available until now. Previously, director or secretary had to download and email observations to interested parties. Now people can do it for themselves. And it's not been possible without the efforts of the database secretary, Andy Wilson, to whom Roger is eternally grateful. So if you want to have a look, go into our website and you can do a search. I don't know if it's possible now to go online.
So currently, how is the reporting or submitting the observations being done right now? So if I would want to submit some observations,
yes,
how would I do it?
Right, well, hopefully I'll show, if you can go to our website, I'll show you how you can do that.
Oh yeah.
Are you a visual observer?
Visual, yes.
Right, so that's two methods. One is to use an Excel spreadsheet, and the other is to use a script.
Yeah.
And I'll show you if we can get onto our website. Right, if you want to put your visual observations in, there's a visual report form.
Yeah.
And as I said, there are two methods. One is to use an Microsoft Excel spreadsheet.
Yeah. You have some kind of pre-formatted.
Yes, we do.
Yeah.
It takes a while.
So you can put it in that format. And I think that's the easiest method of doing it.
Yeah. And then this is been sent by email or downloaded?
Yeah, just download it by email and it will come through to us.
Yeah.
And in those estimate column, those letters A and B refer to the names given to the conversions are in your own house.
And that will simply download. And we're using the same, the CCD observations use a piece of software, it's AIW for Win, and it will, that piece of software will enable you to do photometry, and then once you've done that, that data will be automatically linked from that piece of software into our database.
Yes.
And is this database also linked somehow to the EuroVS?
Well,
is it separate?
we do have links to the EuroVS, and we're always a bit careful about how one should actually submit the data, because there's a jeopardy of recording two sets. So if I were to record my observations to the EuroVS and into our own database, if there's a link between the two, my observations will be counted twice. So, I mean, I'm based in the UK and I have access to, if I need advice, I speak to my own people. We also prepare, I haven't mentioned, we also prepare our own charts. So, I'll pick the first star I started on, which was EuroVS. And so if you're looking at it visually, it's easier to see this, the charts, if you copy it and paste it into a Word thing. And we record the comparison star magnitudes underneath. So we have a link to Hendon. And that's the other organisation which you see, Astronomical. That's the TA chart catalogue. There's another chart catalogue we have. And
no, you can't access it without the member.
it requires a username and password, which I don't have on me.
Yeah, just cancel it, yes.
Well, I think that concludes my presentation today. If there are any questions.
How many CCD users do you have?
I think that was in the demonstration. I think it showed the total number of CCD observers. They are increasing in number, but it's the cost, isn't it? setting up a telescope with a CCD camera, and I think that's been a deterrent for a lot of people. But as the price of CCDs comes down, I think we'll see more and more people using them. And of course the other thing with the CCD, it's not quite, you need a much better mount and pointing facilities. I changed my mount, which is in my back garden, from something that had a really good pointing facility when I'm doing visual observing. Now I've got a CCD camera. I sit in my garage, in nicely and warm, and I use Seal, which is a free piece of software to point the telescope, find a star that's quite close to the object I'm looking at. So if, say I'm looking at M101, I'll go to Eta Ursa Majoris and then move the telescope from that point. And it's reasonably accurate with CCD to move my telescope from say one part of the sky to another, say several degrees. The main problem is when the equatorial mount flips sides. Unless the telescope is completely in line with the mount, you'll get an error, and it's of course twice the difference. So the big advantage of my Astrophysics 900 mount is you can continue observing past the meridian for up to 6 hours.
There's software to correct things. And make your data solving right.
I mean, you can, I think, there are several methods of doing that. One is if you use Maxim DL, it's got a facility called MaxPoint, which I've not tried. And the other is T-Point. If you want to go for T-Point, you have to buy software disks, the SkyX, and the T-Point's an add-on. And I believe that is a lot more efficient in its pointing accuracy than MaxPoint.
Lots more expensive.
And it's a lot more expensive when you think you can buy, Seal, which is a very good free program. And you can download, it will find any variable star that you want to look for, and it will find an asteroid. I think there are 2,000 asteroids recorded. The big disadvantage of Seal, if you're looking for asteroids, is that it's not linked to the Minor Planet Center.
You can download yourself new orbital elements, put them in.
Yes. So with I think every other piece of software here, for example, there's I think there's 6 or 7 different pieces of software where the Minor Planet Center has a link, and I've sent them an email saying, can't you put Seal on it? Because if you could, you can then, on the Minor Planet Center's website, you can select the asteroid you're interested in, and it will come down. But the variable's no problem. It's got all the NGC objects on it.
I think there's even free software for pointing.
It would be nice to have a piece of free software.
Yeah, there is. which you can find at wherever you're pointing on the scar. I forgot the name because I'm using CCD Commander and you need MaxIMPL pinpoint for blade soldering. But there is something else, but I forgot the name. But it's free.
Well, I'll go for it. Anything free I go for.
Yeah. You can use MaxIMPL, principle, you can try CCD Commander, it's very good. And it has, I think, 45-day free access. So for pointing, I mean, if you move from west to east on your mount, and you do not have a good pointing, you can at least correct it.
Well, I've got Maxim DL, so
Yeah, should work.
so I'll try that.
Yeah,
Thank you very much.
CCD Commander.